Okay, so today I'm going to explain the 5 theorems to prove triangle congruency. And the 5 theorems are side angle side, SAS, side side side, SSS, angle side angle, ASA, angles angle side, AAS, and finally hypotenuse leg or HL. And basically I'm just going to give the definitions and examples of each theorem. And hopefully I can explain these well enough for even a monkey to learn. So, the first theorem is the side angle side or SAS theorem. If two sides and the included angle are congruent to the two sides and the included angle of the second triangle, then the two triangles are congruent. The included angle is basically just like the vertex or meeting point of the two congruent sides. And the easiest way to tell if angles or sides are congruent is by the signs. For the sides, lines are used, and if they have the same number of lines, then they are congruent. Same with the angles, except curves are used, and for right angles, a box is used. And in this example, we'll be answering the question, are these triangles congruent, and if so, by which theorem? And we will be answering these same questions for all of the examples. So here we have two right triangles. Two of the sides are congruent, as you can see by the signs, and since both triangles are right triangles, the angles have to be congruent since they are both 90 degrees. Therefore, yes, these two triangles are congruent by the SAS theorem because two sides of one triangle is congruent to two sides of the other, and the angles in between them are congruent. Yay! On to the next theorem. Okay, so the next theorem is the side-side-side or SSS congruence theorem. If three sides of one triangle are congruent to three sides of a second triangle, then obviously these two triangles have to be congruent. And as you can see here, all sides of this triangle are congruent to all the sides of the second triangle. And we are given two triangles in this next example. Are these triangles congruent? I don't know. Let's find out. So these sides are congruent, so are these, and also of course these sides are congruent too. So yes, this triangle is congruent by the SSS side-side-side congruence theorem. Next, I'd like to apologize for the change in lighting. The sun was setting and I had to turn on my light. Anyways, this theorem is the angle-side angle congruence theorem, aka ASA. And it states that if two angles in the included side of one triangle are congruent to two angles in the included side of a second triangle, then the two triangles are congruent. This theorem is kind of like the side angle side theorem, except it's flipped, where it's two angles in one side instead of two sides in one angle. And here you can see that these angles are congruent, this side in between these two angles are congruent, and this angle on the outside is also congruent to each other. Okay, now for this example. Here we have two triangles. Wait, only two things are marked. It's okay, because we know that these two angles are congruent because they are vertical angles. So this angle is congruent to that one. This side is equal to this one, and that angle is congruent to this one, but which theorem? Since the sides that are congruent are in between the angles that are equal, these triangles are congruent due to the angle-side angle theorem. Come on, only two more theorems to go. You can do this. Okay, so this next theorem is the angle-angle side or AAS theorem, and it states that if two angles in a non-included side of one triangle are congruent to two angles in the corresponding non-included side of the second triangle, then the two triangles are congruent. This non-included side is the side that is not in between the two congruent angles given, and in this example, the angle is congruent to that angle is congruent to this, and these sides are both congruent to each other, so yes, these triangles are congruent. Since the sides that are congruent aren't in between the angles that are congruent, these two triangles are congruent by the AAS theorem, but But finally, we are on the last theorem and it's the final stretch, so don't give up. The good old hypotenuse-leg congruence theorem, or HL for short. This one states that if the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and the leg of a second right triangle, then these two triangles are congruent. And I have to stress that these triangles have to be right triangles. If you can't prove that it's a right triangle, or it doesn't have the box that shows you that it is, then it is not a right triangle and you cannot use this theorem. Anyways, in this example, we have two right triangles. Yes, the hypotenuses are congruent, and yes, one leg of the triangles are congruent to each other, which means that yes, these triangles are congruent, and since I have said this before, right angles always equal each other. That means these triangles are congruent by the hypotenuse-leg theorem. Hooray, you made it through! I hope that you understand these 5 theorems way more clearly now, and that I helped you in that process. And so thank you so much for joining me in this video, and I'll see you next time. Bye.